Hi, my name is Paige, and in this video I will be doing my best to explain molecular geometry using balloon models. I will try my best to represent each of the electron domains for each of the molecules. And the first one we're going to start with is, by the way, I have notes on my side, so if I look over, that's what I'm looking at. But the first one we have is ethane, which has two bonding areas. One triple bond is on each of the carbons, or is on each carbon, yes. And then there's 0 non-bonding areas. This forms a linear shape for both the electron domain and the molecular geometry. Hybridization for this is sp. The bonding angle is 180 for this, and it is nonpolar, and no effect is made since the triple bond is still in domain for this one. And next we have boron trifluoride, which consists of 3 bonding areas with 0 non-bonding, and the electron domain and the molecular geometry for this is both trigonal planar. The hybridization will be sp2. The angle that this forms is 120 degrees. And there are no lone pairs. This is nonpolar. And 3 of these, so I've got 3 balloons which would form around the central atom, if you think about the center being the central atom. So for the nitrite ion, there are 2 bonding areas and 1 non-bonding. The electron domain is trigonal planar. The molecular geometry for this one is going to be bent. Hybridization is sp2, and the bond angles is about 115 degrees. So, and for this one, the lone pair compresses a little, compresses the angle a little bit, and this one is polar. So this forms the trigonal planar, excuse me. Next up we have the phosphate ion, which consists of 4 bonding areas and 0 non-bonding areas. Both the electron domain and molecular geometry have a tetrahedral shape. The hybridization for this is sp3. And the bonding angles is about 110 degrees. All single bonds are symmetrical, and they are nonpolar. For phosphorus trichloride, we have 3 bonding areas and 1 non-bonding area. The electron domain is tetrahedral, and the molecular geometry is trigonal pyramidal, and the hybridization for this is sp3. It's about 107 degrees for the bond angles on this, and the lone pair reduces the angle. This is also polar. Okay, next we have nitrogen dioxide. This one is going to look a lot like nitrogen ion, but because it has 2 bonding areas and one non-bonding area, so the electron domain is trigonal planar. The molecular geometry is going to be bent. This is caused from the lone pair. The lone pair causes the bent shape. And then the hybridization is sp2 for this. and it is polar. For phosphorus pentachloride, we have 5 bonding areas, 0 non-bonding, and for the electric domain and molecular geometry, this is going to form a trigonal bipyramidal shape. The hybridization for this will be sp3d, and the bonding angles will be 90 degrees, 120 degrees, and 180. It is symmetrical in shape, and it is nonpolar. For sulfur tetrafluoride, we have 4 bonding areas and 1 non-bonding area. The electron domain is trigonal bipyramidal, and then there's a seesaw shape for this one. The hybridization will be sp3d. The bonding angles is 90 degrees and about 120 degrees. The lone pair tends to distort the shape for this, and it is polar. For SF6, there will be 6 bonding areas and 0 non-bonding areas, making this nonpolar. The electron domain and molecular geometry holds a octahedral shape, and the hybridization for this is going to be sp3d2. The angle is about 90 degree angle for each bond. It makes the perfect shape, no lone pairs, and there's 6 of these balloons. And then for iodine pentachloride, there are 6 bonding areas and 1 non-bonding. The electron domain is octahedral, and the molecular shape is pyramidal. As you can see, it kind of looks like a pyramid-ish, an ugly pyramid. And the hybridization is sp3d2. The bond angle is about 90 degrees. The lone pair for this distorts the shape and makes it polar. So that is it for this video. I hope you have a little bit of a better understanding. It did allow me to visualize each of these molecules by a hands-on experience. And thanks for watching.